In this video, you will learn how to solve a literal equation. A literal equation, sometimes known as a formula, is just an equation that has one or more variables, and we have to be told what variable to be solving for. So I just have a few examples here, and you'll notice that they are examples similar to the kinds of problems that we've just been doing. The first one is a rational equation or a fractional equation, and we know that f, m, and p cannot be zero. If any of those were zero, we have something that did not make sense. Our least common denominator here would be f times m times p. So I am going to multiply each one of these by f, m, p just so that I can get rid of the fractions, and then I'll worry about solving for the for the p in this case. So in the first one, our f's will cancel and we get mp. In the second one, our m's will cancel and we'll get fp. And in the third one, our p's cancel and we'll get plus fm. So p is actually in two different terms. It's in this term and it's also in this term. So we have to get the p's, the terms with the p's, on the same side. So I am going to subtract fp from each side. And because those are not like terms, I can't combine them, and I have two different p's, and I need only one. So what we do in that case is we factor the p out, like this, and then we divide by the binomial m minus f. So in this case, p is fm divided by m minus f. You can try that again and solve for m and see what that would look like, but it's very similar. For our next example, we have a radical equation. We've just dealt with a radical equation and we want to solve for c. So remember, we're going to isolate, raise, and solve. And in this case, we've got, we should also check. We know that L cannot equal 0 and also C cannot equal 0. Because if either one of those were 0, we would have something that was undefined. So our radical is already isolated. So I am going to square both sides. That gives me w squared equals 1 over LC. My least common denominator here, hopefully you see, is LC. Remember, we can put this over 1 if we need to. So if I multiply by LC, I'm just trying to get rid of the fractions. I get LCW squared equals 1. And then I want to solve for C, so I'm going to leave the C there, and I'm going to divide by the LW squared. So we get C is equal to 1 divided by LW squared. So all we have to say here really is that L cannot be 0 and W squared cannot equal 0, which means W cannot be 0, because those values would make the denominator 0. Of course, we already knew these two conditions as well. All right, for the last example, we have a fractional exponent. And if you recall, a fractional exponent, a to the m over n, is the nth root of a to the m. So what's in the denominator there is our index here, and then the numerator becomes the exponent. We can also write this as the square root of a raised to the m. So sometimes that's more beneficial. So we're going to rewrite x to the 1/3 as the cube root of x. Our radical is isolated, and now we will raise it to a power. But to get rid of a cube root, we have to cube both sides. So in this case, we get x equals -8. And we should check our answer. If I have the cube root of -8, is that in fact -2? And the answer is yes. So this is not extraneous, a valid solution. For the last example, we also have a rational exponent. So the first thing I would like to do is rewrite this using a radical. So this is going to be the cube root of x minus 3 squared equals 2. So our radical is already isolated. We will raise it to a power. Now in this case it's a cube root, so we are going to cube both sides. The cube root and the cube go away, so we have x minus 3 squared equals 8. At this point I have a couple options. I could multiply out the x minus 3. I could FOIL that and get a quadratic and move the 8 over. Or I could do this and take the root of each side. Just don't forget to take the positive or negative root. And so we have x minus 3 equals plus or minus the square root of 8. And remember that the square root of 8 can be broken up as 4 times 2, and we can take the square root of 4, so we get 2 root 2 plus or minus 2 root 2, and then we will add 3. Now we should check our solutions. In order to do that, I'm going to find these two values as a decimal. Otherwise it's going to get super messy. 5.828 and 0.172. So the first one is 3 plus 2 root 2 and the second one is 3 minus 2 root 2. And of course, since I rounded these, my answer is going to be really, really close, but not exact. So we're going to do 5.828 minus 3 to the 2/3 equals 2. 2.828 to the 2/3 is 2. And if I do this in my calculator, I will get 1.9997 equals 2, and that's just rounding error. When I check the second one, I get 0.172 minus 3 to the 2/3 equals 2. And using my calculator here, I also get 1.9997 equals 2. And again, that's just rounding error. So that concludes this video. Make sure that you practice some of these literal equations and those with the fractional exponents.